Alright, this is Math 2, Unit 8, Lesson 1, looking at circles and arc. This is homework help for the problems that are listed right there. It's a lot of problems listed, but a lot of these will go pretty smoothly for you. I'm only going to do portions of the problem so we can save some time. Alright, so first of all, looking at number 1, looking at what minor arcs are, just recall that minor arcs are going to be arcs within the circle that are less than 180 degrees, which means there are going to be several minor arcs in here. One minor arc could simply be just from C to D, and so you'd write that as CD with that arc over the top. So there are other ones, DE, and so on. A major arc, if you recall, is an arc that is greater than 180 degrees. Okay, so if you find 180 as being, for example, C to F, that's we'll get there in a second, a semicircle. If I wanted to go larger than that, I could take something like I can do B. I can start here B, and I can go around this way. I can go B and around F all the way to C this way here. And with a major arc, you're going to have 3 letters in it. So I can do B and F and a C and call that a major arc. So I'm picking up this one, and that one. Would it matter if I called it BEC? Nope, not really. That's another way because it's another point along that curve. So there are several ones that are also going to be major arcs. I'm just going to list one just to give you an example. Remember, a semicircle is going to be equal to that 180 degrees. It's half of it. And I already mentioned one before. That would be something like going from C to F is a semicircle, and that's how you'd write that arc there. But I want to include, sorry about that, my middle point, the B, sorry. So I would say CBF. Okay? I'll write the little nicer, so CBF as my semicircle arc. Okay, looking down here at this next section, it's a whole lot of problems connected to this one circle right here. One of the things I'd recommend doing is before you start to figure out all the little parts here, go ahead and take a look at the circle, and as you're looking at it, go ahead and try to figure out what are these measurements that are listed here. They listed one as 114. This space here is going to be 90 degrees because it's listed there already. It's 90 degrees. I can tell that I have a diameter here going across this circle. Now, because I remember from before supplementary angles, the sum of these two parts will be 180 degrees. So to find this space right here, I would do 180 minus 114, and when I subtract that there, I come up with 66. So this space is a space of 66 degrees inside of there. As a result of that, I can go, okay, that's 66 to 114. This is the diameter. That means this portion right here is also supplementary to the 90. I have a 90 degree here, and the supplement to that is going to be 90 over here. So at this point, what I have is I have all my sections of the circle all with a measurement, with a value, 90, 90, 114, 66. So when I move over here to the questions, and I go, okay, what do you want me to do? UT. Well, UT is right here from this point to that point, and they already gave me that. It has a measurement of 114. So that was a given. When I look at number 5, 5 says, what is the measure of arc ST? ST is here, here to here, and we determined that already as being 66 degrees. When I look at SV, SV is here to here, and we determined that already, figured that out as 90 degrees. Now for the rest of these, it's going to be a combination of going from SV to U to SV to T, and you have to do a lot of addition to figure that out. Let me give you one example. Here's USV. So USV means I start here at the U, and I go all the way around to the S, and keep on going to the V. So what that means is that any number between here and here, I'm going to add up to find out the arc of USV. Well, from U to T, I had 114 degrees, here to here. From T to S, I have 66. And from S to V, I have 90. So all we're going to do is add those together. 6 and 4 is 10, carry the 1. 10 and 6 and 1 is 17, carry the 1. And I have 270 degrees is my answer for number 11. You'll do the same thing for the remaining questions as well. Just a lot of addition. Okay, moving down to number 17. Number 17, same idea. It says find each indicated measure for circle D. Now again, they gave me this angle measurement here of 70 degrees. They did not give me the others. So I can use some math and what I know from before to figure out what this could be. I notice that here I have a diameter from EDG across the circle, which tells me that this space right in here is going to be the supplement to my 70 right there. Well, 180 minus 70 leaves me with 110. So that tells me that this space is going to be 110 degrees. Okay? Now I have another diameter right here. So because that's a diameter, I have 110 over here, which tells me what's missing over there, or I already figured that out. It's 70 degrees. I can also look and notice that because I have two diameters crossing, that these are vertical angles, so I have 70 and 70. That leaves me then with these angles right here. It does note that these two angles are the same. They have this little mark on it there and there to indicate these are the same. So if I have two angles of the same, I know their sum is going to be equal to the vertical angle across 110. So I'm taking basically the angle measurement of 110, flipping it over here, and I'm going to divide it into two portions. So instead of having one angle, I have two because they're going to be equal. And 110 divided by 2 is 55. So that indicates to me that each of these little sections is 55 degrees. From there, I can go ahead and solve the remainder of these problems. And for example number 17, the measurement of angle EDI, here's EDI, right here in this space, is going to be equal to 70 degrees. And I would do the same thing with the different angle measurements and arc questions there as well. Okay, looking at number 23, it says find the value of each variable. We're looking at the variable, it's going to be A. Alright, so look at this one here. What I notice is that I have a diameter, XY, that goes across circle W. Well, because it's a diameter, that means that this angle plus this angle is going to equal 180 degrees. So I'm going to set up it as an equation. I'm going to take the 2a minus 45 from here, and I'm going to add that to the a from here, and I'm going to set that equal to what it should be, supplementary angle, 180 degrees. By doing that, I combine like terms. 2a plus a is 3a, and I'm going to add 45 to this side, and I'll move that over there, adding 45. So I end up with 225. So 3a equals 225. I want to get the a by itself, so I'll divide both sides by 3 and arrive at the conclusion that a is equal to 75 degrees. And that's all you have to do for number 23. All right, looking at the back side, we're going to look now at the first part has us dealing with circumferences of circles. And then works with the formula here. The circumference is 2 pi r. Nothing wrong with that. 2 pi r is the circumference formula. Just remember, this is something I remember. Oh, sorry. Pack it up here. That formula for circumference, while it can be indeed 2 pi r, it can also be pi times the diameter. Because a radius, or if you have a radius and another radius, you end up with just the diameter. So there actually are two formulas you could use. The book's going ahead and your worksheet is using this form here, 2 pi r. That's no problem at all. But as you notice in your work, you have some where they give you a diameter. So don't get stuck by going, well, I don't know what to do. You could cut that in half if you want and figure out what it is. But if you cut it in half, all you're going to do is multiply it by 2, so you're back to having the diameter. So it's up to you. I'm going to do number 27 real quick here, just as an example. So we have this 27, we have the circumference is equal to 2 times pi times the radius, which in this case happens to be 5.8 inches. So when I multiply that out, 5.8 times 2 is going to be 11.6, and I still have pi. So that's my answer for number 27. The purpose of doing that is to know, okay, I'm looking at the circumference, which is the area distance around a circle. Now that I know how to find the distance around a circle, they move into finding the length of the darkened arc. We're trying to find these arcs. We're looking for basically now not the distance around the whole circle, but just a portion or a fraction of the whole circle. You see, if I wanted to find the circumference of this circle, I would use the same formula. I would do circumference equals 2 times pi times the radius, which is 9, end up with 18 pi. Well, that's great, except that we don't want to know the whole thing. We just want to know that little bit there where I have a 20-degree angle measurement for that arc. So I want to know just this portion of the circle. So to do that, they say to start with a ratio for that measurement of the arc. So we have 20 degrees out of the whole circle, which is 360. So they say 20 out of 360 there, which you can reduce that down to 1/18. Okay? Now I'm going to take that measurement there. I'm going to take the 1/18 and I'm going to use that to multiply together with my, I can do it with my diameter, I can do it with diameter, or I can do it with the 2 pi r. So let's go ahead and keep using the formula they gave us up here, which is 2 pi r. I'm going to do 2 times pi times my radius, which is 9. Okay? So I'm using my formula from up above. My circumference equals 2 pi r, and I'm basically taking that and now adding to it this fraction, which shows I'm doing a portion of the whole circle. Alright, so 2 times 9 is 18, so if I kind of keep working this out, I have 1/18 times 18 pi. 18 over 18 reduces down to 1, so I'm left with just pi as the answer for number 29. Okay, so that's how that one can be solved there. So to figure this out, your formula you want to use here is you're going to take the measurement of your arc, okay, I'm going to just write it like that for you now, divided by 360 times pi times the diameter, or if you don't have a diameter, you could do the measurement of the arc divided by 360 times 2 times pi times r. So either one of those is going to work for you to figure out what the length of a fraction of one of these circles is going to be. So let's look at one more here. We have number 30, and I have here a 10 centimeter radius. I have an arc length of 90. So when I work this out and plug in my different parts here, I would say that I have 90 out of 360, that's my measurement of the arc length over 360, times, and they gave me a radius, so I'll go ahead and keep it like this, 2 pi, and my radius is 10 r, 2 pi r. So it's using this formula here and plugging in the values there, and now I just have to work that out. So when I do work that out, I can multiply and have 2 times 10 is 20, 20 times 9 gives me a nice big number as well. So I end up with a mess basically. When I work all this out here, I'm going to end up with 5 pi when it's all said and done. Okay? And again, I could reduce that for you. I could do 90 over 360 first. I could make the zeros go away. 9 over 36 is the same as 1/4. 1/4 times 20 equals 5, and that's how I get down to there. So anyways, that's how I work that stuff out to get to the 5/4. Let's show you one more example here from today's work. One of the word problems here says, hands of a clock suggest an angle whose measure is continually changing. How many degrees does the minute hand move through during each time interval when looking at a 9-minute interval? What we're doing here is we're setting up a simple proportion, right? So in a regular circle, a circle has 360 degrees. For a clock has 60 minutes inside of it. So every minute is one of those 60. So we're comparing a circle with 360 degrees to a clock with 60 points on it, essentially. So because I'm looking at a 9-minute interval, I'm looking at 9 minutes out of the 60 on my clock. And I want to know, how does that relate to a circle? Well, I don't know what the arc of that circle is going to be, but I do know that what I'm looking at here is that it's out of 360. So what I'm asking is, 9 minutes out of 60 is the same as what arc measurement of a full circle. And so once I set the proportion, now I can go ahead and solve this. I can reduce 9 on 360 down to 3/20ths because 3 goes in there 3 times, 3 goes in there 20 times, and set it over to x over 360. And then I can go ahead and cross multiply, and 360 times 3 is 1080 equals 20x. Divide both sides by 20, and then we're left with x equals 54. So that means that the distance from big hand on the 12 down over here to 9 minutes, that arc distance there, this is not the 9, but the 009 minutes, is 54 degrees. All right, and that's it for this lesson. Thanks.